morning, everyone. Let's see, I'm alive. Yes, indeed. And welcome to another episode of Xah Talk Show. Today is July 20th, 3 minutes after midnight. So this is 3 minutes, July 20th. And today we are going to talk about Lisp. The Lisp language, the Lisp syntax. So actually, I'm not ready yet. Let me actually be back. The Lisp syntax. Let me show you some of the things we're gonna talk about. So programming languages. So Lisp, yes. So we're gonna talk about Lisp. Lisp language family and Lisp syntax and stuff. Let me show you. Actually, I need to be back in 5 minutes. So Lisp Lambda tool. This is Scheme Lisp. Fantastic logo. Now, okay, so okay, let's see if do I have people. 0 people. Good. So I will be back in 5 minutes, and hope to see you soon. Hey guys, hey Daniel, hey Mr. Etherflow, great name. So how you guys doing? So today, we're gonna talk about Lisp syntax. Lisp syntax, s-exp, which stand for symbolic expression, and m expression, which stand for meta expression. And it's a fascinating topic. And right now it's midnight here, so I have to keep my voice low. I live in an apartment, a cheap apartment in Mountain View, California, which is close to San Jose, and the rent is $2,200. I share with roommates. It's one bedroom, a two bedroom, $2,200. Okay, so let's talk about Lisp. Let's see. Yeah, there are some things I want to cover. Okay, let's go to my programming blog. Let's begin. Begin at the beginning. Alice says. So are you guys ready? Ready? So there is the Racket scheme Lisp. They are planning to ditch the parenthesis syntax. You can see, I don't know exactly what's the deal yet, but they have news. It's over, it's over social network. People are talking about it. They are, so current leader, I think, is Matthew Flat. He's the current leader of Racket language, and apparently they are creating a Racket 2 version 2. And I think so they are thinking, maybe they want to change the Lisp syntax, no more nested parentheses or something like that. I mean, they are exploring the possibilities. So he's talking about it. You can read it here. But these Lisp people, there's many questions. So let me write down what we're gonna talk about. Okay, what I want to talk about. So Racket 2 is planning a new syntax. Okay, that's first thing. Then I'm going over to what I'm going to talk about. So talk about let me see. So Racket scheme. This is unscripted, real time talk. So you are seeing me. My thought flow is working live. No censorship. No 5 minutes delay. No bleep of offensive words. If there's any offensive words coming out, you get it directly. So okay, so I have quite a few things to. Okay, let me think. Okay, guys, type something that invokes my enthusiasm on this subject. This is, actually this subject is not too popular because Lisp is kind of a dying language. Not many people, programmers, are into it. Okay, let me think. I want to talk about. Okay, let me just start talking random. That way that's more fluid. Usually, that way I get more things to start to talking. So anyway, Racket scheme is a Lisp language. It's a branch of scheme. So let me show you. So what is Racket? The Racket scheme is. Let me show you. I have an article here. So here you can see the Lisp family of languages. So in 1955, John McCarthy, he thought of, invented Lisp. Now, the original purpose of Lisp is sort of math-based language. So Lisp is actually I think it is the first language based on mathematics. I mean, in a sense that they are trying to. Anyway, anyway, it's a one. It's a language based on ideas of mathematics as opposed to number crunching. For example, one of the first language that's for number crunching is Fortran. I don't remember what year is Fortran, 1950s, something around there. So anyway, this is one of the first, or the first math-based language. So John McCarthy, and it's the reason it's invented is partly because the artificial intelligence research. People, we are starting to do artificial intelligence. Daniel Langlo is always gives the some like popular opinions. I do not necessarily agree. It's like you hit you often you hit the spot I want to talk about, because that is exactly the topic, the hot spot I want to talk about people's Lispers think other people, those people who don't like parentheses, they think those people don't get it. They think they are beginners, but actually that's not true. In fact, the Lisp, you guys know what's Lisp parentheses, right? In fact, the Lisp parentheses, expert Lispers, one of, the people at the top, the master of Lisp, they always, often it is them, they want to create a new syntax that's not nested parentheses, because nested parentheses has lots of have a few practical problems. So the practical problems of purely nested paren syntax. Okay, that's one of the issue. Let me talk about that. And okay, so Lisp began, in 1995. Then you have several versions. You have Mac Lisp, Interlisp, like the few I know. Actually, I have some, Emacs Lisp I know very well. Emacs Lisp is over here, so it began in 1987, around there. Okay, and Common Lisp is one of the most popular. Common Lisp and Scheme Lisp. Basically, the most popular Lisp today is Scheme Lisp, Common Lisp, Emacs Lisp. You can, if you want to include that, it may not, should not be, because Emacs Lisp is actually just a scripting language within Emacs. It's basically practically useless outside of Emacs. So Scheme Lisp, Common Lisp, Emacs Lisp, and Closure Lisp today. These four are basically the most popular, and in fact, Closure is actually the most popular in actual industry. Closure. And Emacs Lisp. In fact, if you count popularity, Emacs Lisp, if you count the number of people who actually code the language, Emacs Lisp is probably the most popular, because there are still a lot of people using Emacs, including me, and we code Emacs Lisp because it's practical, even though it's not really a full-fledged programming language. You essentially you only use it within Emacs, the editor. So here's the Lisp history. Oh God, so what am I going to talk about? So let's go back to the let's go back. So Racket scheme Lisp, they want to create a new language. Okay, so here is the things I want to here are the articles I want to talk about. Lisp, which address your comment, Daniel Langlois. So one of the first thing is the Lisp infix syntax survey. So like I mentioned, a lot Lispers, Lisp fans, Lisp fanatics, often, yeah, typically Lisp fanatics, they think the Lisp parentheses. By the way, if you guys don't know what Lisp look like that, if you guys don't know what Lisp look like, let me show you. Let's see, because I have a lot of Lisp code. This is what Lisp look like. So let me show you. So let's go to the beginning. So this is one of my Xah keys Lisp package. So this is what Lisp look like. It's all parentheses. For example, let's go. So define, for example, this is a block of code. And for example, this is a if statement. So if this condition is true, then do this. Otherwise, do that. That's Lisp. Let's see if I can. So lots of lots of parentheses. This is parentheses hell. So and common Lisp, scheme Lisp closure, they all look similar. Basically lots of parentheses. Actually, let me show you a funny thing, funny picture. Let's see. By the way, guys, comments, okay, post your opinions or whatever. Or even if you have opinions that's different from mine, post it. Post it. It's good to talk about. Let me show you. There is a very funny picture. Oh God, there's so many things I want to talk about. So on Lisp, actually, here is a collection of articles I've written about Lisp. Why so many? Because in 1990s I programmed Mathematica for 10 years. And Mathematica is a language. It's based on Lisp and APL. I'm not going to show APL, but it's based on Lisp and APL. So Mathematica, is actually you could say it's a family of Lisp, because Mathematica is a Lisp, because every characteristics of Lisp you will find it exactly the same. I mean, not exactly, but you'll find it in Mathematica. Like many people question, often in Lisp community there's a question like, how do you what is Lisp? For example, the logo language, the Dylan language, the for example, logo language, Dylan language, they don't use nested parentheses syntax, but however they are actually they are based on, they are essentially Lisp but with a different syntax. So often when people debate online, people about talk, and programmers, they want to say, they debate about things. So exactly how you define Lisp, the way I define Lisp is that you have a few characteristics. Okay, so let me type it out. Lisp characteristics. Okay, and one is nested paren. Okay, and symbolic, you have symbols. By the way, yesterday I did a 1 hour talk show that is about Lisp, pattern matching, and symbolic. What's the meaning of symbolic language, Lisp, and pattern matching and Lisp macros yesterday. So check it out, yesterday's video. So what's the characteristics of Lisp? When can you say a language is Lisp or belong to the family of Lisp? So I would say one is nested parentheses. Two is it must be symbolic. It has symbols. I'm not going to explain. I did explain it yesterday. And nested. So what are the other characters? What are others you guys might suggest? Symbolic, nested parentheses, list oriented. Okay, that's a fundamental thing. List. Everything is a list. And functional programming. Okay. So I would say these four. These are the main characteristics of Lisp. Any language, if they satisfy these four, I would say it's Lisp. So first of all, nested parentheses. If you really count nested brackets, let's say purely nested. Let's not say pure, because Lisp is actually not pure. So nested brackets. Why do I say bracket instead of parentheses? Because Mathematica, for example, Mathematica, you don't use parentheses, but rather you use the square bracket. Everything is, the whole thing is nested brackets. In fact, the syntax is 100% pure nested brackets. It's even more pure than Lisp, because Lisp has several exceptions. I'm going to show you. Okay, let's talk about purity of nested brackets. Okay, Mathematica versus Lisp. Lisp syntax is actually not pure. Okay, not pure or regular. Okay, that's one thing we're gonna talk about. So anyway, we're gonna talk about Lisp characteristics. This okay. Then let's talk about pure nested brackets. Yeah, let's talk about it. Let me show you why Lisp is not 100% regular, the syntax. So let's go back to fundamental problems of Lisp. Okay, this article. Now you see, so in general, when we think of Lisp, we think of everything like this. So you have parentheses, then you have f, a function name, then you have arguments. So everything is like parentheses. Each item in the parentheses may be another parenthesis. Nested. So typically we think of Lisp syntax as that. Sometimes you hear Lisper say Lisp has no syntax. That's silly. Every language has a syntax, and so we typically we think of Lisp as that, but actually it's more than that. It's irregular. It's not regular. For example, comments. Lisp comments is like that. It's based on starting with a semicolon and ending with a new line. That's not nested parentheses. Now you look at this. This is called a const cell. You have parentheses, then you have a dot. Now that dot is not a symbol. It's not any character. It must be a dot. Like two items and in between a dot. That's called const cell. Okay, that's not regular. That's because then suddenly you got this dot as part of the syntax. It's so it's not regular. Then you have this quote syntax. Okay, you put this tick apostrophe in front of parentheses. That's not regular. And then you have backtick. Now if you don't know Lisp, I'm not going to explain. This is Lisp language detail, but anyway, you have this backtick. Basically, essentially it means okay, you have this backtick. Okay, then inside the parentheses you have comma in front of a symbol. So essentially what it means is that when you have a backtick, it means hold evaluation of the following expression. Don't evaluate it except at places where there's a comma. So when you have this, that means don't evaluate the x here, but do evaluate the x over here because there's a comma in front. This is called what does Lisp call it? I'm not sure. I forgot the name. Backward. Anyway. So anyway, you have this syntax backward with comma. That's not regular. Okay. Then you have comma with the at sign. Like this. That's not regular. Okay. Then you have oh yeah, the vector data type, right? That's right. Yeah, the vector data type. Then you have square bracket. So I'm not going to and this these all these so far we talked about happens in emacs Lisp and common Lisp, you know, and also I'm not sure in scheme Lisp. Some of them may be different, but anyway, at least it happens in common Lisp, emacs Lisp. Okay, then you have in scheme Lisp you have others. Okay, so my point here is that Lisp syntax is irregular. Okay, contrary to most people, Lispers think. So 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 we've talked about purely. We talked about how Lisp syntax is not pure. Okay, let's see. We covered that. Then I'm going to tell you, I'm going to show you. Okay, first of all, it's not pure. And so what's the problem? I mean, so there's a significance of the consequence. For example, I give some examples. For example, in my opinion, it's confusing. It breaks syntax semantic correspondence. Lispers usually like to say, "Oh, in Lisp, data is program is data." Idiotic. Okay, the reason in Lisp you have this called homoiconicity. Okay, the reason of that is actually not because of Lisp or something. The heart of that property is because the syntax is 100% regular. For example, another example is XML. Okay, that is the thing. It's not because of the data or data is program is data. That's not undefined. You will not find you will not find a precise definition of that concept in the context of Lisp. You can go to Wikipedia, homoiconicity. They will try to define it, but the way they define it, then you'll see that assembly language also qualify. You have a bunch of languages that's not nested parentheses, they all qualify as homoiconicity. Fuck the programmer's jargon. Let's look it up. Iconicity, homoiconicity. This term started to become popular around 2008. Around that. There it is. You can go and read Wikipedia about that, but I'm not going to talk about that homoiconicity. Okay, but basically, if you look at that, you will see. Let me show you. You see, so all these languages qualify. Julia, Prolog, Rebo, Red, Snowball, TCL, XSLT. So it basically it ceases, it stops becoming what you like to believe. Lispers, they like to believe, the nested bracket qualify, but by this definition, you can see it. They don't, it becomes something else. Then, so anyway, so I explained so I'm going to so Lisp syntax is actually not pure. Okay, not regular. Okay, I explained that. Let me explain. Then we also explained homoiconicity. Okay, let me do this. Homoiconicity, the property, the Lisp property often phrase as program is data is called homoiconicity. This is actually yield defined, okay? Yield defined, and this term became popular around 2008, something like that, okay? And it's yield defined. If you look at Wikipedia, then you will see that lots of other languages not based on nested bracket also qualify as homoiconic, okay, iconic, okay. That's one thing we okay, so that's one thing we explained, okay. Now the next item, pure. So are there languages that's, we have showed that Lisp syntax is actually not regular because of you have the, these irregularities, and we also explain homoiconicity, the heart of the concept program is data is actually the heart of the Lisp concept program is data is actually due to regularity of nested syntax. Now this is my opinion, okay. Sometimes I may wonder, if this is like you may question, are you just cooking up things? It's up to you to decide, okay. So in my opinion, the heart of, because I'm not a renowned computer scientist, so when I say something that's contrary, people doubt it. But in my opinion, I tell you, the heart of the Lisp concept program is data, data is program, that is actually due to that property is due to the regularity of nested parentheses as syntax, okay. Not anything else, not the anything else. Okay, so let's talk about so what language. So okay, before we talk about Mathematica, there is also what's wrong with irregular syntax, and what's alternative. For example, I show you. Let me I talked about several issues with the irregular syntax. So and I talked, in this article, I talked about the advantage of pure 100% regular syntax. So for example, one of the good thing about that is, program is data. Data is program, like XML. Okay, XML around 2000, throughout year 2000s, it's very popular idea, but it got killed by HTML5, which is not good. Okay, but anyway, so the advantage of 100% pure nested syntax, one of them is that you have the program as data idea, okay. And in turn, you can do symbolic pattern matching, like computer algebra we talked about yesterday. And also you have universal formatting, okay. For example, like Go format, okay, universal, automated, and also you have the property of syntax as markup language. You could do that. For example, what do you mean syntax as markup language? For example, HTML, or XHTML or MathML. That, you know, when you have a purely nested syntax, it becomes easy to use the syntax as a markup language. It becomes simple. Okay. So anyway, we talk about Lisp language syntax is not regular. we have seen examples. So what are language Mathematica? It is a language whose syntax is 100% nested. No irregularity. It's For example, let me show you example. Okay, let me show you example here. So you can see here is an example of Mathematica code. Look at this section. Okay, you can see everything is in this form. Okay, everything. F square bracket, then whatever inside is nested. F square bracket, whatever, F square bracket, whatever, and they may be separated by comma. So in Lisp, you separate items by a space, but in Mathematica you separate items by a comma. In Lisp, you start a expression with a parenthesis. In Mathematica, with a parenthesis. In Lisp, you start the expression with a parenthesis, and the first item is a function name. Now, in Mathematica, you begin with a function name, then followed by a square bracket, then nesting. So that's a difference. You kind of swap. You take the Lisp, Lisp function name. You take it outside the parenthesis. Then you change the parenthesis to a square bracket, and you change any space to a comma. That becomes Mathematica syntax. Okay. Now this is Mathematica syntax. You can code it Mathematica this way if you want, but actually nobody does that. So and okay, my point here is that Mathematica syntax, you see, this is pure. There's no exceptions. There's no, oh, here you put a you put a apostrophe for quote. Oh, there you put a there's nothing like that. So that's an example of a pure Mathematica syntax. Okay, now the next thing I want to talk about, here's the important thing I want to talk about. Before we do that, so you see Mathematica syntax, they are isomorphic to the Lisp syntax. Imagine a pure 100% pure Lisp syntax without all these irregularities. If you have that, then Mathematica syntax is isomorphic to the Lisp syntax, meaning that, for example, this Mathematica code, you can transform it to the Lisp code like this. So, if we imagine it's Lisp, it would look like this. You take the any function name, you move it inside the bracket, like that, and you change the square bracket to parenthesis, and you replace the comma sign by a space, then you have that. So you see these two are isomorphic. In math we say isomorphic because there is a one-to-one correspondence. you know so so one big thing I want to talk about is the s-exp and what is mexp. Okay, meta expression, s-exp and meta expression. That's one thing I want to talk about. Okay, before I do that, let me read the comments. Oh my god, I've been talking for 40 minutes already. Shit, I haven't begin yet. So yeah, Daniel says I can explain the main reason why people hate Lisp. Complete ignorance of Lisp is the reason. That's not true. That's totally not true. Okay, let me address that right away. So anyway, so this, I mean, because I was trying to do some kind of more organized, but usually random chat is I get, if I do random chat usually the flow continues. So, oh yeah, so why so I have this page. I did a survey of Lisp infix syntax. So in Lisp community, especially Common Lisp, many seasoned Lispers hold the idea that those who dislike Lisp's nested parenthesis syntax are outsiders. Who don't get Lisp. That is incorrect, factually incorrect. So this page lists Lisp projects or languages that implement alternative syntax to solve the controversial nested parenthesis problem. Okay, so throughout history, the Lisp history, you are many people, Lisp experts, people in Lisp community. They need, because there's a need. Because why nested parentheses? It's got practical problems. Let me talk about that first. What is the practical problems of purely nested syntax? Okay, so what is the problem? For example, if you want to do mathematics, for example, 3 plus 5, let's say squared, times 7. Suppose you want to do that in Lisp. It gets, it's unreadable. This just, as simple as this one, it becomes unreadable. In fact, I have many articles on that. Let me just pull up an example somewhere here. Okay, let's go to fundamental problems of now let's go to, yeah, the here. Okay, the concepts and confusions of prefix, infix, postfix, and Lisp notations. Now this article discusses the differences, or the history, or the kind of math background of these different notations, what they mean. So you can see we have a picture here, example. But right now, what I want to say is that, oh yeah, so I want to say that, purely nested syntax has some practical problems. The most obvious one is that when you want to do a lot of math, for example, the quadratic formula, any formula becomes unreadable when you write them in the Lisp style. For example, I have, let's see, well, I have it, some article in, okay, where is the article? The meaning of operators. Okay, let's search Xah, the meaning of operators. Okay, in that article I have example showing you how. Okay, I have two articles here. This one is what's the definition of operator in computer languages. Now that's an interesting article. In fact, there is actually no definition of operator in computer languages. They each one differ. There's no precise definition. That's interesting article, but it's not really. It's another thing to what we are talking about. So here, what's a function? What's an operator? So okay, so here you see examples. Let me get over here. So you see here example of traditional notation using operators. Okay, and yeah, so you can see. So let me show you where. Okay, there is another article actually, not this one. Oh, okay, here, fucking ads. So here is the Lisp expression. this is the quadratic formula in this expression. You see, it's not readable. But if you okay, anyway, so what is we talking about? So yeah, so here is about the practical problems of purely nested syntax. This is the main problem, because this is the main problem when you do math. Lisp syntax is not readable. For example, like in emacs, you have calculators. Calculator everyone needs to use. Every Mac OS you have a calculator. Windows you have one. People need to calculate groceries, and and the way I do it, I usually don't use those calculators. Instead, I just open up, for example, JavaScript. For example, save it in the, I open a file uh, in JavaScript, and if I want to compute, I just say 3 plus 4 and run it. That's how I do calculators. 3 plus 4 minus 10 times 20, for example. That's how this way, the advantage of this you have, because you have an editor. You can change things. You see the whole history, and you can do variations, if you want. For example, minus 21. This is how I do, when I want a calculator. So I'm using JavaScript right now, you see, but for sometimes I was using Python. And for some time, I thought, let's just use Lisp, for example, Emacs Lisp, because in Emacs Lisp, I can, at any time, I can, compute without opening, for example, 3 plus 5, okay? Evaluate that, we see 8 at the bottom, you see 8. So, I thought, oh, let's just use Lisp, but it's impractical, because, for example, if you want to do this, okay, then you have to, 3 plus 4, then minus, okay, minus 10, then you have to, okay, yeah, you have to actually, wait, the whole thing, you have to say times, then 27, you see, so that, hold on a second. So, for example, let's do that. So let's run this. Okay, run this JavaScript. What is the answer? Negative 193. Okay, now let's try the Lisp. Okay, the syntax is wrong. I mean, okay, so 3 plus 4 minus 10. Oh, okay, 3 plus 4 minus 10. Okay, minus 10 times 20. So this is actually should be 10 times 20. So the whole thing should be like that. So let's run it. 193, you see. So you can see it's problematic, it's impractical. So that is the let me get this. Okay, so that is the example. Okay, example Lisp. Okay, example JavaScript. Okay, is that in this is, okay, for example, that is the practical problem of the nested syntax. One of the problem. This is the main problem. There are other small problems. Okay. So yeah. Okay. Green Deck says, what about calculate? Calc mod, which is a very popular utility in Emacs. I don't use that. I used to use it 10 years ago, before, but I stopped using that because the Emacs, we are digressing, but let me talk about that for a bit. The Emacs calc mod is very popular. It was the most advanced piece of software in the entire computing history. Okay, this is in 1990s. Okay, it's actually the most advanced one. Let's say one of the top 10 most advanced piece of software. But as time moves on, Calc mod is stays that way. And basically Emacs just stagnated. But anyway, so I don't use that because today, since let's say 5 years ago, you can use JavaScript, Python. You have much far more flexibilities than using Calc mod. Like I mentioned before, like let's do this. Okay, so that's JavaScript code. That's Emacs Lisp. Okay, for example, uh, okay, let's say JavaScript. Okay, so JavaScript, if I want to do sine cosine, I can start to code, math pi. I can, in other words, I can load libraries, I can do algebra or what, not so much in JavaScript, but in Python, for example, I can, when you talk about Python packages for doing math or more advanced algebra, it's far more powerful than Calc. And also the other advantage is that when you have a code, instead of using Calc mod, which is like a calculator, but rather you write code, it's much more flexible. You can keep a history and so on. And another advantage is that you can learn the language. For example, you just picked up a new language, let's say Julia or whatever. You know, you can learn it. So anyway, so that's this. I got. I haven't got to the main point I want to talk about, which is M expression. That is actually the more important, more interesting. But okay, so let's see what we've talked about. Lisp syntax is actually not pure. Okay, and the Lisp property, often called program data. Okay, we talked about that, and purely nested brackets. For example, Mathematica. Okay, and then the practical problems of nested syntax. Okay, that's what we just covered. Then we also covered why not use Calc. Okay, because it's simpler, more flexible, because using a real programming language such as Python is simpler, more flexible, more powerful. Okay, Calc has not been updated for like over 10 years. I mean, they still maintain it, but the features and it's not, not today. Today is not good. Okay, we covered that. So let's talk about s-exp and what is m expression. Actually, let me read the comments first. Okay, so oh yeah, so Daniel says why people, so I talked about so Lisp, the nested parentheses actually. So you got problems, and almost every year, Lispers they have tried to create an alternative expression. In fact, the Lisp inventor John McCarthy, when he created Lisp, when he got the idea, he wanted, there are two syntax. One is s-expression, which is nested parenthesis. We are used to it. It's called, the S stand for symbolic expression, and the other syntax is called M expression. That stand for meta expression. Now, John McCarthy never actually fully specified what M expression is going to be like, but today on Wikipedia, you can see some of the historical documents and discussion what is kind of like. Okay, it's never specified fully as far as I know. So actually, but it was never actually implemented because people started to use s expression and they like it, so m expression is kind of, according to Wikipedia, it's indefinite, it's put into indefinite delay, it just never uh, picked up. But the important thing to know is that actually John McCarthy, the alternative syntax is actually his idea. That is part of Lisp. Okay. Then you have 1973. All these people are well-known computer scientists because I looked up history. So this guy created he created CGOL. Siegel is an alternative syntax for the Mac Lisp programming language. Okay, by this guy Vaughan Ronald Pratt. Okay, he's all these are computer scientists. The and then you have Mathematica, well known today because Wolfram Alpha, Wolfram Research, Stephen Wolfram. So then you have Dylan, which is you have a lot. I'm not going to go through. So what's the point? The point here is that Lispers, they think, so why are Lispers have this false idea about how Lisp should be nested parentheses, and how anyone criticize it is beginner. Lispers like to say, oh, beginners always think they should have alternative syntax until later on, then they finally got Lisp, then you know they accept the nested parentheses. That's just bullshit. Okay, that's totally untrue. And Okay, so that's about that. Okay, and I'm going to talk about meta expression. Okay, let's talk about meta expression. Meta expression is the idea from the Lisp inventor, but it never got implemented, except it's done in Mathematica. Okay, Mathematica has that. Mathematica, if you read Stephen Wolfram, he created Mathematica. The history, the Mathematica, is based on Lisp and APL language. APL is the APL is a language with lots of the weird syntax. Let me show you. Let's not show it. I don't have time today. So what time is it? 15 an hour already. So guys, type something. Okay, type type stuff. Uh, so what I want to say. Yeah, M expression. Oh, okay. So in Mathematica, Stephen Wolfram, he actually implemented M expression. So before, like we showed before, this is Mathematica expression. Okay, this is purely nested. Pure. There's no exceptions. You start with a symbol, then bracket, square bracket, then whatever, separated by comma. Okay, this is Mathematica expression, but Mathematica syntax actually it's they have what's called so what is M expression? So this one, the nested syntax you see, it's like Lisp. It's in Lisp you call it s-exp, but in Mathematica this expression you call it full form. Okay, full form, meaning it's fully spelled out, full form. But Mathematica offers an alternative. Mathematica syntax is actually like they have a layer. They have the M expression layer. So this code you see here, start with set delayed, can be written like this exactly. can be written like this. These two are syntactically equivalent. Now this is a critical idea. Okay, they are syntactically equivalent, meaning that any part of this expression, any part of mathematical expression can be transformed into the m expression. So in other words, you can say it can be transformed between s-exp versus mexp. They can be transformed by just pressing a button in the editor. I don't have Mathematica installed here, but Mathematica editor looks like that, notepad. Okay, so this is called so in Lisp you have the idea s-exp and m expression, but in Mathematica they actually did that, but they don't call that, they don't call s-exp and m. They call it, the full form. This is full form, and this is called input form. Okay, and any part of it can be transformed to the other by just pressing a button. You can select part of it. For example, this part square, two numbers, square root of two numbers. You can select it, press a button, and it becomes this. You see? Let me get rid of the. You see? So you can start to see how they correspond. They can be transformed on the fly because they are syntactically equivalent. They are. Let me mention another thing. So you have in Mathematica you have the full form, which is like sexp. Then you have the input form, which is like m expression. Okay, they can be, they are isomorphic. They can be transformed, any part or the whole thing or the whole entire source code. You can select the entire source code, like 10,000 lines, press a button, they can be transformed into full form or input form or standard form. They have another form. You can see this. They look like two-dimensional traditional math notations. They are rendered into two-dimensional traditional math notations. Now this form is called, Mathematica calls it standard form. So again, any of these forms can be transformed into each other, on the fly. The standard form is a bit special because it requires rendering, because it's like tech. It's two-dimensional. It's not. On the other hand, the full form and the input form are just sequence of characters. So that's Mathematica. It's very so that's Mathematica. So the important thing I want to talk about is the equivalence, the meaning of syntactic equivalence, and the meaning of sugar syntax. There's a huge confusion among programmers about sugar syntax. Okay, let me write it down here. The confusion of the concept sugar syntax and the meaning of syntactically equivalence. Okay, so that is the thing I'm going to talk about. So let me read the comments. Okay, maybe I'll talk about 10 more minutes, and that'll be it for today. It's kind of late here, so hold on a second. Let me read the comments. So some people use rainbow parentheses highlighting to this. Yeah, so I tried rainbow parentheses. I didn't find it particularly necessary. I find it this way is fine. It just highlight the parent. Yeah, the issue, everyone has opinions. You can use rainbow parent. I don't use it because for me, I think you have so many colors. It's actually not not easy to see which one matches what, as one would imagine. you know I would imagine when I first discovered that, rainbow, oh, it's great because you can immediately see which one corresponds to which, but it turns out it's not that simple. I mean, yeah. So that's just my opinion. So Daniel says Lisp without paren comes up pretty regularly and never catches on. I've learned to love the parents. Okay. Yeah, that's one of my points. So you see these Racket 2 people, they the Racket 2 people, they wanted to, they are trying to think of alternative syntax for Racket 2. So it's happened again. And so there's one thing I don't understand, because because to me the issues, all these fuzz about Lisp syntax and alternative syntax, to me it seems to me can be easily solved by adopting, the idea of syntax layer, that is m expression. You have six symbolic expression, you have m expression, the way Mathematica is done. To me, Mathematica solved the problem in the most elegant way. So I do not understand, all these, many of these are, these experts and computer scientists. I do not understand why they, they do not, what is their thought about this? Why didn't they adopt the idea of, m expression, syntax layers? So, and today, the Racket 2 people, you know today is led by Matthew Flat. He's a professor and, computer scientist. So I don't understand. So, I want to ask him, uh, you know like I want to ask him, why didn't you thought, what do you think about, the meta expression layer, as John McCarthy suggested, but it's difficult because I cannot, it's difficult to get the answer because I cannot just go ask him because he, in this community, he doesn't know who I am, and in this community, anyway. So, but anyways, all these people, the Racket researchers, they must, a lot of them must know. They must be aware for sure. And many of them, I suppose, know Mathematica. They have experience. But why didn't they? Why didn't, the M expression get, adopt that? Why didn't they? But before we talk about M expression, I want to emphasize the idea of syntactic equivalence. That is part of the M expression as implemented in Mathematica. It is important to know. You see this when you see this and this, it's important to understand that these are syntactically equivalent. That means the underlying structure is still this. There is no, like, when the compiler sees Mathematica code, the first step is to transform everything into the full form, into the symbolic, the nested paren, thing. So so in so so this so we could say this is the sugar syntax. This is the sugar syntax in the most purest form. Now let me explain. This is important because many people got it wrong. Because, for example, in Python, let me explain. The concept of sugar syntax and meaning of syntactic equivalence. For example, x equals to 3 versus x equals to 3 without space in between the equal. That's syntactical equivalent in most languages, because the space doesn't matter. And for example, Lisp quote x versus a backtick x, those are syntactically equivalent, because when Lisp compilers sees this, it before it tries to find out what it means, it syntactically turns that into a list like this. So they are syntactically equivalent. Now let me show you. So what's a example of not syntactic equivalent? For example, in C, you have I plus plus versus I equals to I plus 1. Now in C language or C++, you have that, C I plus plus or I equals to I plus 1. That is not syntactically equivalent, because it tells the compiler it actually do different things. But even to us, the outcome, the effective outcome is usually the same. That's the key thing. Here's the key. They are not syntactically equivalent. When two syntax are syntactically equivalent, that means they are 100% semantically equivalent too, because when the compiler tries to parse it, it just transforms one to the other. So there's no, it's the same thing, exactly the same thing, 100%. But on the other hand, for example, this C thing is not, it's not the same. And let me show you another example. Another example in JavaScript. Let's say function f x something, okay, versus f equals to function x. Okay, here is the example in JavaScript. These two are not syntactically equivalent, even though most of the time they have exactly the same effect. So this is the important thing about sugar syntax. Sugar syntax is a popular term. So people, a lot of people think, oh, this is just the sugar syntax of that. Oh, this is just sugar syntax of that. Oh, this, but there's a distinction. Some of them are syntactically equivalent at the syntax level. Before the compiler do anything, they just transform them to the same thing. And on the other hand, many syntax shortcuts, they are totally not, syntactically equivalent. So back to Mathematica. So I was saying, so in Mathematica, this full form or s-exp and this m expression, or the input form, all these three are syntactically equivalent. That's the important thing to get. Anyway, let me read the comment, and I think that's it for today, because I've been talking for actually an hour and 15 minutes. Okay, so let's see. So Lisp seems to have too many useless names in its base library. Example. For example, prog n versus block. By the way, there's also prog n1 in Lisp, in emacs Lisp. Let's see if I can show you that. Prog1, okay. Yeah, that. So you can see, you see there's a prog1. Here's the documentation. So anyway, by the way, in Mathematica, you have the same thing. For example, prog n in Mathematica is that, okay? So in Lisp, you have prog something something code. In Mathematica, it's called, I'm pretty sure, if I recall correctly, it's compound expression ... So this traces back to what I was saying. So the if you find the characteristics of Lisp, being symbolic, nested brackets, functional programming, and what's the other characteristics I mentioned? Um, nested brackets, symbolic, list oriented, functional programming. Every item is in Mathematica. As you've seen nested brackets in Mathematica. Symbolic, check. In Mathematica, it's just like Lisp. Every identifier is actually a symbol. You can get, you can quote them. In Mathematica, you don't say quote, you say hold, or you say unevaluated, hold form or hold. And list oriented, we've seen, in Mathematica, everything is a list like this. This set delay is this giant list, and this vector angle is, this, list. And functional programming, just like Lisp. But Mathematica is not pure functional language, just like Lisp. You can do loop, you can assign values, and so on. So anyway, so I think let's wrap up. Yeah, I think we've already actually we covered all the things. Most of the things I want to talk about today. So Danielle says Lisp seems to have too many useless names. Okay, and Danielle says if you don't like car and cadre, write first and rest. uh, and set Q is pretty nasty and harder to avoid. Okay, so what about okay? So Mathematica code design is elegant. So but symbols are global and there's no lexical scope, which does not scale. That's not true. I mean, depends on what you mean. In Mathematica, for example, I haven't coded Mathematica for 10 years, but in Mathematica, for example, you say module. I can actually still remember the syntax because I coded for so much. For example, body. So this is the Mathematica syntax. This is equivalent to Lisp's let. Okay, this is equivalent. For example, xy, and these two are equivalent. Now you may complain, these two are equivalent, okay? But however, the way Mathematica implement this lexical scope is by actually it rewrites these variable names into a global variable name. In other words, it will create a global variable name named something like that. Okay, and some random number. That's how Mathematica implemented this. Now in Lisp, actually it's similar. Okay, yeah, it's similar. You have, just like Mathematica, uh, you have the how what's the called symbol table. There's a name. Anyway, and I'm not going to go into detail. Let's see. We can go to eLisp. So go to my emacs Lisp, and you can see eLisp symbol topic. So we cover Lisp symbol, Lisp special form, what's a function. So let's go to Lisp symbol, and you can see we talk about symbols, and we talk about there is a thing I want to find. Op array, yeah, that's a word. Op array. Op array in Lisp, I think also common Lisp, is basically a table of symbols. Like every symbol you ever used is in op array. Not every technically, but vast majority. So, in a similar way, Mathematica is that. Anyway, so nothing scales. Okay, yeah, that's true. I think that's it for today because I've talked long. Um, anything else? What's up? If you intend it is applied mathematics. Okay, yeah. So for me, the question I have is that I really want to ask, the Racket 2 people, these computer scientists, what do they think, why is not M expression a, good solution? I don't really understand. So anyway, yeah, that's it for today. So thank you guys for watching. So if you haven't said hi yet, say hi. Okay, uh, if you like my stuff, go to my website and any page. There's I got Patreon, PayPal, and you know put money in my box. So bye. See you guys. Have a good day.